This is the timeline of mathematicians under the Greek Hellenistic mathematics. Euclid, the father of geometry, started his civilization in the year 300 BCE, followed by Archimedes, the father of mathematics, on year 287 to 212 BCE. Then Eratosthenes from 276 to 194 BCE. Apollonius of Perga, the great geometer, from 262 to 190 BC. Hipparchus of 120 BC. Heron of Alexandria, 10 to 70 AD. Menelaus of Alexandria, 70 to 140 AD. Diophantus, father of algebra, from 200 to 284 CE. And last, Hypatia, 370 to 415 AD.
What is Hellenistic?
The term Hellenistic means Greek-like, derived from Hellen, the word that ancient Greeks used to describe their civilization. The period following Alexander the Great is sometimes called the Hellenistic mathematics.
Alexander the Great of 3rd century BCE. By the 3rd century BCE, in the wake of the conquest of Alexander the Great, mathematical breakthroughs were also beginning to be made on the edges of the Greek Hellenistic Empire. In particular, Alexandria in Egypt became the great center of learning under the beneficent rule of Ptolemy, and its famous library soon gained a reputation to the rival of the Athenian Academy. The patron of the library were arguably the first professional scientists, paid for their devotion to research. Among the best known and most influential mathematicians who studied and taught at Alexandria were Euclid, Archimedes, Eratosthenes, Heron, Menelaus, and Diophantus.
Euclid from 300 BCE. The Greek mathematician lived and flourished in Alexandria in Egypt around 300 BCE during the reign of Ptolemy, the father of geometry, great chronicler of the mathematics during the late 4th and early century BCE. He invented classical or Euclidean geometry. He also wrote the Stoicheion or Elements. Euclidean geometry is the study of geometrical shapes and figures based on different axioms and theorems. It is basically introduced for the surfaces or plane surfaces. Geometry is derived from the Greek word geo, means earth, and metrien, which means to measure. Euclidean geometry is better explained especially for the shapes of geometrical figures and planes. This part of geometry was employed by the Greek mathematician Euclid, who has also described in its book Elements. Therefore, this geometry is also called Euclid geometry.
Archimedes. He was known throughout most history of his inventions like the Archimedes screw. However, his true love was pure mathematics, and his discoveries provided new insights on how he obtained mathematical results. Some of his methods are method of exhaustion and derivation of the surface area and the volume of the sphere. Method of exhaustion. Archimedes used the method of exhaustion as a way to compute the area inside a circle by filling the circle with a polygon of a greater area and a greater number of sides. The quotient formed by the area of this polygon divided by the square of the circle radius and be made arbitrarily close to pi as the number of polygon sides become large, proving that the area inside the circle of radius r is pi r, being defined as the ratio of the circumference to the diameter.
Archimedes used the method of exhaustion to compute the area inside a circle. Derivation of the surface area and volume of the sphere. Surface area of sphere. The surface area of sphere is the area occupied by the curved surface of the sphere. Circular shapes take the shape of a sphere when observed as three-dimensional structure. For example, a globe or a soccer ball. Let us learn about the formula of the surface area of the sphere and how to calculate the surface area of the sphere in this lesson. What is the surface area of the sphere? The area covered by the outer surface of the sphere is known as the surface area of the sphere. A sphere is a three-dimensional form of a circle. The difference between a sphere and a circle is that a circle is a two-dimensional shape or 2D shape, whereas a sphere is a three-dimensional shape. The surface area of the sphere is expressed in square units. Observe the sphere given below, which shows the center, the radius, and the diameter of the sphere. The formula area of the sphere depends on the radius of the sphere. If the radius of the sphere is r and the surface area of the sphere is s, then the surface area of the sphere is expressed as surface area of the sphere equals 4 pi r squared, where r is the radius of the sphere. In terms of diameter, the surface area of the sphere is expressed s equals 4 pi times d over 2 to the power of 2, where d is the diameter of the sphere.
Eratosthenes, an astronomer, geographer, and a mathematician that first devised the system of latitude and longitude, as well as remarkable degree of accuracy of calculating the circumference of the Earth. His greatest legacy as a mathematician was the sieve of Eratosthenes. Eratosthenes measures Earth's circumference mathematically using two surface points to make the calculation. He noted that the sun rays fell vertically at noon in Cyrene and erected a pole in Alexandria where he observed that it cast a shadow, proving that the sun was not directly overhead but slightly south. The sieve of Eratosthenes is a simple algorithm to identify all the prime numbers up to any value.
Apollonius of Perga, 240 to 190 BC. He was a Greek mathematician known as the Great Geometer. His works had a very great influence on the development of mathematics, and his famous book, Conics, introduced the terms parabola, ellipse, and hyperbola, which are familiar to us today.
Hipparchus, who was also from Hellenistic Anatolia and who lived in the 2nd century BC, was perhaps the greatest of all ancient astronomers. He revived the use of arithmetic techniques first developed by the Chaldeans and Babylonians and is usually credited with the beginnings of trigonometry. He calculated the distance of the moon from the earth by measuring the different parts of the moon visible at different locations and calculating the distance using the properties of triangles. The table of chords. Hipparchus invented the table of chords, a list of the ratio of the size of the chord of a circle to its radius associated with the angle from the center of the circle that spans the chord, the equivalent of the sine function in trigonometry.
Hipparchus and trigonometry. Hipparchus founded trigonometry by computing the first trigonometric functions, namely a chord and a tables. Hipparchus was not the only founder of the trigonometry, but also the man who transformed Greek astronomy from a purely theoretical to a practical predictive science. He also introduced the direction of a circle into 360 degrees. Geometric construction used by Hipparchus in his determination of the distances of the sun and moon.
Heron of Alexandria. Heron or Hero of Alexandria was an important geometer and worker in mechanics who invented many machines including a steam turbine. His best known mathematical work is the formula for the area of triangle in terms of the length of its sides. Heron's formula: A is equal to square root of S times S minus A times S minus B times S minus C, where S is equal to 1 plus B plus C all over 2. Menelaus of Alexandria, the first to recognize geodesics on a curved surface as the natural analogues of straight lines on a flat plane. His book, known as Pyrrhica, deals with the geometry of the sphere and its application in astronomical measurement and calculations, and introduced the concept of spherical triangle. Spherical triangle is a figure form of three circle arcs, which named trilaterals.
Diophantus, a Hellenistic Greek mathematician, sometimes called father of algebra, and wrote a collection of algebraic problems called Arithmetica. He was the first to recognize fraction as numbers and apply quite complex algebraic problems, including the famous Diophantine equation. Diophantine equation, an equation involving only sums, products, and powers in which all the constants are integers and the only solutions of interest are integers. For example, 3x plus 7y equals 1, or x squared minus y squared equals z cubed, where x, y, and z are integers. The Diophantine equations fall into three classes: those with no solutions, those with only finitely many solutions, and those with infinitely many solutions. For example, the equation 6x equals 9y equals 29 has no solutions, but the equation 6x minus 9y equals 30, which upon division by 3 reduces to 2x minus 3y equals 10, has infinitely many. For example, x equals 20, y equals 10 is a solution, and so is x equals 20 plus 3t, y equals 10 plus 2t for every integer t, positive, negative, or 0. This is called a one-parameter family of solutions, with t being the arbitrary parameter.
Hypatia is famous for being the greatest mathematician and astronomer of her time, for being the leader of Neoplatonist school of philosophy in Alexandria, for spectacularly overcome the profound sexism of her society, and for suffering a violent death at the hands of ignorant zealots. She did work on algebraic equations and conic sections. She invented the astrolabe for ship navigation and devices for measuring the density of fluids. Astrolabe for ship navigation. The instrument was used to help determine the ship's latitude from the height of the pole star or of the sun. At night, the pole star was sighted directly through small pinholes in the two vanes mounted on the pivoting alidade or rule. Another invention that she created was the hydrometer, for which an instrument used to measure the specific gravity of liquids, that is, the ratio of the density of the liquid to the density of water.